All right, this section is about functions. All right, now let's start with a definition. Definition of a function can be as follows. For every input value, there is only one output value. Okay, that's a rather formal statement. Let's say it informally. Two people can go to the same room at the same time, but one person can't go to two rooms at the same time. All right, now what do I mean by that? Well, let's take this example right here. I have person number 1 and person number -4. Okay, and they can both go to the same room, room number 10. So we would say f of x is a function. All right, f of x takes the input of 2 and gives an output of 10, and takes an input of -4 and gives an output of 10. And that's perfectly fine. F of x is a function. However, let's take this. Person number 7 can't go to room 3/4 and room -9 at the same time, right? So g of x is taking an input of 7 and giving two different outputs to it, all right? G of x is not a function, all right? Okay, now let's look at some table of values. And I have an input in the left-hand column and an output in the right-hand column. Notice that I have an input of -2 being taken to an output of 0, and input of -9 being taken to an output of 0. That is perfectly fine. They both go to the same room, room number 0. That's okay. So f of x is a function. However, let's take a look at this data set, and notice for an input of x and an output of g of x, the same input is taken to two different outputs, and that's not good. Person number 5 can't go to two different rooms, all right? By that analogy, that's not okay. So g of x is not a function, okay? All right, now let's do the same thing, talking about it, but with a graph instead. Notice if we have x is equal to -5, it is taken to an output of +3, all right? But x is 4 is also taken to an output of +3. That's okay, all right? That's okay. So g is a function. Now looking at this graph, if I have x equals 2, what is h of x? Well, if x equals 2, we have an output of +6, and we have an output of -2. That's not okay, all right? Same input taking two different outputs. So h of x is not a function. And to make this simple, we have what's called a vertical line test, which says if any vertical line intersects the graph of f of x only once, then it is a function. If the line intersects f of x more than once, then f of x is not a function. So looking at our earlier example, a vertical line, if you move this vertical line anywhere on this graph, it's only going to intersect g of x once. So therefore, g of x is a function. Taking a look at our second graphical example, if I put a vertical line, say right there, it intersects it twice, all right? And by the vertical line test, h of x is not a function. Okay, that's an easy way to tell. Okay, here are some for you to try. So pause this video and apply the vertical line test to these 4 graphs, and which of these represent functions and which do not. All right, coming back, what about the one on the upper right here? If I put a vertical line right there, notice it intersects it actually 3 times, so that is not a function. Okay, what about on the upper right here? I'm putting a vertical line, just mentally taking a vertical line and going all the way to the left and to the right. I see that it only intersects it once, so that is a function. All right, what about the lower left here? Applying a vertical line there. Here's actually okay at x equals -2 because that's an open circle and that's only a closed circle. So a vertical line here will actually only touch the graph once right there. So that's okay. Applying it, keep going to the right. Oh, look at right there. Right there, the vertical line intersects it twice. And because of that, just because of this area right there, that means that that one's not a function. Okay. And then what about this one over here? Circle. Well, I can put it anywhere pretty much within the circle's domain almost, and I'm going to intersect it twice, so that represents not a function. Okay. All right. Now, there are other names that we can call inputs and outputs. We can call the input the independent variable, and that makes the output the dependent variable. All right, the input will be the domain, and the output will be the range. And most of the time, we have the input being x and the output being y. Okay. All right, so these are other names that we can apply to the inputs and outputs. All right, so now let's take next example. Let's take this one right here. Okay, if x is equal to 3, what is the output? In other words, what is f of 3? Well, we've done this before, right? You just plug in 3 into f of x and do a little math, and that turns out to be 49. Okay, so review, right? All right, let's do this example. F of x equals this. What if y plus 3 is the input? What is the output? In other words, what is f of y plus 3? Okay, so once again, we do insert y plus 3 in for x, and then we evaluate. Okay, so we have to square this binomial, which you can do by FOIL or box method, or there's a shortcut way. If you square a binomial, the product or the square is the square of the first term, double the product, and square the last term. That's what you get here. Square the first, double the product, square the last. And you can prove to yourself that that works using FOIL method or box method or whichever method you want. If you square a binomial, that's what you'll get. And then keep just carrying the rest of this along. And now let's distribute. So 4y squared plus 24y plus 36. Distributing the 6, we get this. Okay. Then we have some like terms here, and we have some like terms there, which we can combine, and our final answer is that right there. Okay. And as a final example using this function, what if smiley face is the input? What is f of smiley face? Okay. Well, once again, just plug in smiley face, and that's where you get. And you're done. So take whatever it is the input and insert it into the function, f of x or g of x or whatever. Okay, one last exercise, identifying the independent and dependent variable. Now there's some key English that we need to interpret depending on how it is worded, okay? So, for example, the dependent variable depends on the independent variable. Okay, so if you see the word depends on, whatever comes before is the dependent, whatever comes after is the independent. Okay? The dependent variable is a function of the independent variable. So once again, if you see the words is a function of, whatever comes before is the dependent, whatever comes after is the independent. The independent variable determines the dependent variable. Okay? So in this case, whatever comes before is the independent, whatever comes after is the dependent. Let's apply that to some statements. Now, if you don't want to memorize this, there's another way to do it too. Is just ask yourself a question. So we have two variables here: the amount of water in the rain gauge and the number of hours it rained. Which determines the other? You know, does the amount of water in the rain gauge depend on the number of hours it rained? Okay, or does the number of hours it rained depend on the amount of water in the rain gauge? Well, I think you'll agree that it was the first one. The amount of water in the rain gauge depends on the number of hours it rained. Okay, so that means that the number of hours it rained is the independent variable, and the amount of water is the dependent variable. Okay, so just kind of interpret the English that way. Or if you want to basically memorize this stuff, you can do that too. The number of hours it rained determines the amount of water in the rain gauge. Okay, so if you interpret the English, okay, which comes before the other? Well, the number of hours it rained comes before the amount of water in the rain gauge, right? So once again, the number of hours it rained, okay, is the independent variable, and the amount of water is the dependent variable. And then finally, wording it like this, the amount of water is a function of the number of hours it rained, okay? Once again, the amount of water is the dependent because that's the one that comes after. So if they word it like this, we can see that once again, the number of hours it rained is the independent variable, and the amount of water is the dependent variable. So you interpret the English to identify the independent and the dependent variable. All right, so that's a little quick review of function stuff. Now, go off and do some practice problems.